Ask My Instructor 9.3.65. A patient receives 5 milligrams of a certain drug daily. Each day, the body eliminates 10% of the amount of the drug present in the system. Estimate the total amount of the drug that should be present after extended treatment immediately after a dose is given. Let D sub n be the amount of the drug present in the patient's system after the nth dose. So D sub n is the total amount of the drug present in the patient's system after the nth dose is given. So after the first dose is given, the patient will have 5 milligrams in their system. Recall that each day the body eliminates 10% of the amount of the drug present in their system. So the next day the patient will still have 90% of the drug present in her system on the day before. Once she adds the second dose, she will have 90% of what was in her system the day before, plus she will now have an additional 5 milligrams. And so D sub 2, the amount in her system immediately after the second dose, D sub 2 will be 5 times 0.9 plus 5. On day 3 of taking medication, the patient will have 90% of the drug present in her system on day 2. When she adds the third dose, she will have an additional 5 milligrams. So D sub 3, the amount of drug in her system, the total amount of drug in her system after the third dose is going to be 90% of D sub 2 plus 5. We put in what we found for D sub 2, and notice D sub 3 is 5 times 0.9 to the 2 power plus 5 times 0.9 to the 1 power plus 5 times 0.9 to the 0 power, if you will allow me to put it that way. Day 4. On day 4 of taking medication, the patient will have 90% of the drug present in her system on day 3, plus an additional 5 milligrams. Since we know what she had immediately after the third dose, we put that in for D sub 3. And then we do the algebra. I would like you to take a moment to look at the pattern. D sub 4 is equal to 5 times 0.90 to the 3 plus 5 times 0.9 to the 2 plus 5 times 0.9 to the 1 plus 5 times 0.9 to the 0. So 0.9 to the 0 is equal to 1. So just want you to notice that pattern, because now we want to generalize. Okay, so think how you would generalize this. Here's one way of generalizing it. On day n plus 1 of taking medication, the patient will have 90% of the drug present in their system on day n, which is the previous day, plus the additional 5 milligrams. Okay, and this is how you generalize it. D sub n plus 1, or one way of generalizing it. D sub n plus 1 is 5 times 0.9 to the n plus 5 times 0.9 to the n minus 1 all the way down to plus 5. And we can put this in summation notation. To find the steady state, we ask what will happen if the patient takes the medication indefinitely. That is, what is the limit as n goes to infinity? and we get this infinite series. Let's review what we know about geometric series. A geometric series looks like this, and the geometric series will converge if the absolute value of r is less than, strictly less than 1. And if the geometric series converges, that is, if the absolute value of r is less than 1, if that's true, then we actually know what the series converges to, what value it converges to. Now, in the problem we're working on, we have a geometric series. The geometric series is 5 times 0.9 to the k, where k runs from 0 to infinity. In this case, our ratio r is positive and its absolute value, therefore, is less than 1. So this is a geometric series which will converge, and there will be a steady state. Alright, so let's use the formula for finding the summation of this infinite series. And we get 50 milligrams. So, immediately after a dose is given, we estimate that the total amount of the drug that should be present after extended treatment, that is the steady state of the patient will, after extended treatment, have 50 milligrams immediately after taking the dose for that day. Take care and have a good day.